Hello, welcome to Microservices Deployment Series Part 1. In this series, we are going to learn how to Dockerize microservices and run these microservices using Docker CLI and Docker Compose. In order to demonstrate this, I have taken one application called Online Store that includes four services: order service, product service, storefront, and rabbit message queue. Storefront is the front-end applications, and order service, product service, and rabbit message queue, these are all back-end microservices. So before discussing how to create Docker images, let's discuss what is a microservice. So microservices it's are a collection of small independent services that communicate with each other using lightweight protocols, usually HTTP or REST or maybe message queues. What are the advantages we get by running our application as microservices? So these are the advantages that I have mentioned here, like scalability, flexibility, resilience, faster development and deployment, reusability, and easier maintenance. So in order to Dockerize the applications, we need a tool that is called Docker Desktop. So that helps in creating the Docker images, and using the Docker images, we can run these services as a container. So for that, you can see here we have different components. We can create a Docker file for each of the microservice, and using the build Docker CLI command, we can build it so that we'll get a Docker image, and we can run it as a Docker container. So if we are running it locally using the Docker CLI commands or Docker Compose, then it will run from our local. It will get the images from the Docker desktop. But if we are going to run this as containers in different other orchestrator tools, like for example, you want to run it in Minikube or Kind or any other orchestrator tool like Azure Kubernetes. So in that case, these Docker images need to be stored in a registry. It may be there are different kind of registries are available. So Docker Hub is one kind of registry where we can store the Docker images. And in order to run it in any other orchestrator tool, we can pull those images from the Docker Hub, or it may be the container Azure Container Registry, wherever it's stored, and we can run it any of the orchestrator tool like the Minikube kind or Azure Container, Azure Kubernetes. Okay, so for that we can pull that Docker images and run it as a container. So we'll discuss this in our future classes how we can do this. So today, but we are going to learn how to run it in locally using Docker CLI command and Docker Compose. So the Docker has different components. Here we can see Docker engine that basically manages the containers. Okay, and we have a Docker file that includes a set of instruction that help in creating the Docker image. And Docker image, it is nothing. It is just include the all the dependencies binaries that is required to run that microservice, and it is immutable. And that means it is read only. We cannot, once the Docker image created, we cannot change it. Docker containers. So what is Docker container? So when we run that Docker image, so the running instance is called a container. Docker Hub is nothing. It is just a repository where we can push our Docker images. Docker Compose, it is a tool that helps in running multiple microservices. So once we create our Docker images, and if you want to run those Docker images together as a application, so in that case we can use Docker Compose. So it will build and run those microservices together to to communicate among those microservices, and also share the data among those. And also we can um, remove or stop those microservices using Docker Compose. The other components are Docker network. So network is like where the microservices or the Docker microservices basically communicate with each other. So there are different kind of networks. The default one is the bridge. Okay. In this application, we are going to create one network that is called the default bridge network, where the microservices what we are going to use is are going to communicate with each other. The other component is a Docker volume. So Docker volume is it is a kind of persistent storage. So if the microservices want to store or share information, so in that case can use a external storage that can persist the data. So usually if we are not using any volume, then if the Docker uh, or the container stops or it restarts, then it lose the data. So in order to persist it, we need to use any Docker volume, that is that will be stored. The data will be stored external to the container. So what is the main difference between a Docker image and a Docker container? So Docker image basically it is a stack of layers. So when we build a Docker image, it will create a stack of layers using the Docker file commands. And these layers are basically non-modifiable. It is non-writable. But when we run or create a container, it will add another container layer on top of this, and that is writable. Okay, so so Docker container is nothing when we run the um, Docker image. Okay, so it will create a container. So it is similar to like if in a programming language, if we compare, so the class itself is like a Docker file, but when it create a create an object, so the instance that you can say as a container. Okay, so here if you see image is nothing, it is a stack of read-only layers, but containers it includes the image layers and also add a on top of this a container layer. Now let's discuss about what is Docker files. So Docker files is nothing a collection of commands, and these commands helps in creating the Docker image. So you can see we have different instructions here from that define the base image, run to execute or run any particular command, and CMD if you want to when we create our container, if you want to by default run any command, then we can define using CMD instruction. There is another one is endpoint. So it defines the main command that always runs, even if you pass any arguments. Okay, and this working directory. So in our container, we can set a working directory where our commands will run. Similarly, for files and directory management, we have copy, add, and volume. So copy from our host machine. If we want to copy the files like our source code and any other related files, we can use copy. Add basically use whenever we want to um, download any files from remotely using the URLs, and volume whenever you want to create any persistent files for the containers. And for configuration and environment, we can use environment variables, arguments, labels, user. So these are different other instructions. For networking, we can use expose if we want to expose a particular port for that microservices for communicating with the other microservices or any other network. And for build optimization, we have these are the different uh, commands or the instructions we are using. And similarly, for security and permission, we have user and CHOW1, that is for setting ownership for copying for the files that we are going to copy or add. Okay, so these are the different Docker commands or the instructions that we include in our Docker file. So for our application, if you see here for each of the services that I have included, okay, we can see there is it includes a Docker file. Okay, and you can see this order service, it includes this Docker file, And remember, for Dockerfile, it doesn't require any extension. And here we have used the from working directory argument copy run, then copy, okay, environment and command. So this is the default command. It will get execute when we'll create the container. So we can go through it. I have just explained in detail what the functionality of these instructions, and this helps in creating when we build that um, Docker using the Docker build. So it will create that Docker image for order service. Similarly, we have for product service we have the Docker file here. These are the instructions. I have already documented it properly. You can go through this. And similarly, we have the storefront. This is the front end application or service, and it is got created. The Docker image is got created using these instructions. Okay, so yeah, so this is the Docker file that we have already discussed. Next is Docker commands. So there are different Docker commands we can see for building our Docker images or deleting or removing the Docker images. Also, we have to manage the containers. We have Docker PS to list of containers. We can use Docker PS, and to run or create a Docker container, we can use Docker run command. So using the Docker image, it will instantiate or create a Docker container. Similar to to stop or start the container, we can use Docker stop commands. Similarly, to see the logs, volumes, and for creating the any network or any volume, we can use these. These are the different commands available. And similarly, to run the microservices or the containers together as an application, in that case, we can use Docker command compose. So the different Docker compose commands are like Docker compose up, Docker compose down. Okay. Okay. So let's. So next step, what in order to do all these steps, we need to install our Docker desktop. So about that, we can follow this URLs I have provided. I'm not going to explain how to install the Docker desktop in different systems. So we can follow this, and from the from from the internet we can get a lot of videos and online documentation to how to install Docker desktop and configure it. Now let's discuss how to Dockerize the microservices. Okay, so here what we can do is, as I told, we are using 4 microservices, but under our the source code here we have only order service, product service, and storefront service. 3 services we are going to Dockerize ourselves, but the rabbit message queue. So we are not Dockerizing it's ourselves. We'll use the available microservice for it from the Microsoft repository. Okay. So for Dockerizing, we can see, as I have discussed already, as we have already discussed, I have created the Docker file for each of these microservices. And here we have, yeah, there is a spell mistake, Docker network. So for that, we need going to create a network, and also you have to create a Docker volume that will help us to adding the plugins to the Rabbit message queue. We'll explain how we'll do this. Okay. Now, let's in order to run these microservices, we have to build our images. Okay, so in order to build our images, we can use this command docker build mine, and we have to specify the path where we are going to take that docker file to build it. Okay, so this is the path source order service where the docker file is available. Okay, so let's go to the docker our bash command here. Okay, and if I'll run this command here, it will try to create a docker image for the order service. Okay, so it will take a couple of minutes to do that. Similarly, we can create our images for product service, storefront service. Okay, and the rabbit message queue service that will automatically will pull it from the Microsoft repository. Okay, and for creating a network, we can use docker network command, and by default we are using the bridge network here, and the name will just take at its backend services network. Okay, now see, you can see this is got created already. Okay, and we can see, want to see, then we can run this docker images command. Then you can see this is already created order service, and the tag is latest. Okay, and it has image id. And if you have, but remember, before to that you have to run your docker desktop. So if you run, and if your docker desktop is running, then you can get a docker ui interface like this. Okay, and if you go to this, you can see there is no containers, but if you go to images, we can see one docker image is available. Just now we have created it. Okay, now if you want to delete this, we can simply delete it using docker rmi remove image. Okay, and here you just mention the image id. Okay, so it is got deleted, and if you go to the ui and try to see the image, it's got deleted. Now it is not displaying. Okay, yeah, so okay, so in order to run these microservices using docker cli, first you need to create the docker images. So here we have 3 images we need to create, and also need to create this docker network. Okay, for communication of these microservices, and we need to run this docker. I mean, we need to create the containers, right? So in order to create these containers, we have to use docker run command and -d, that it will run in background. Okay, so for this we can run this command docker run. Similarly, for this is for rabbit message queue. We can see we are specifying a name, and the restart policy is always. It can be any you can any other policy you can specify here. And network, we have to mention here that what we are going to create here, the docker network. And here we are mentioning the ports, 2 ports we are mentioning here, and 2 environment variables, the username and password we are specifying. And also we have specifying a volume. So this, it is creating a volume here. If you see under our if you go to this, here I have a file called rabbit message queue enabled plugin, and in this plugin we have mentioned 3 plugins. One is the rabbit message queue management, rabbit message queue prometheus, and the one protocol here. Okay, so these are the 3 additional plugins we are going to add to the rabbit message queue. Okay, so for that we have mentioned this volume. So it will take these plugins, read these plugins from the external file. Okay, that will be stored under etc rabbit message queue enable plugins. Okay, that means it will copy this file to this container file. Okay, and if you see what is this 3 plugins usually do, this rabbit message queue management, it will create mainly used for web ui and rest api, and prometheus for matrices endpoints for prometheus and grafana, and this protocol basically for using the message queue. Okay, protocol. Yeah, so this is for creating the rabbit message queue container. Similarly, we can create the order service container. Here also you can see these are the parameters we are passing when we run the docker run command, or when we're creating the order service container. Okay, and here this is for product service. You can see this -e, it mentioned the environment variables. Okay, and p for protocol. Similarly, for storefront, you can see this is what we are using here. This is the parameters. Okay, and at the end, we can see storefront. This is nothing, the Docker image name for the storefront, and for product service, this is for the product service image. Okay, and here the order service is for creating the order service container. And for rabbit message queue, we are using rabbit message queue this, and this is, it will read from the Microsoft repository. Okay, so we can run this individually, but if you want to run together, I have already created one bash file here. You can see run storefront services, one bash file. So what it does usually, it does the same thing what we have discussed. It will create a network, Okay, you can see the network name I have mentioned, and it will create the network. Then it will build the images, Docker images, using this command docker build. Then it will run the Docker. Run means nothing, it will create the containers and it will use, these are the images, okay, whatever it created here in this section. It will run this Docker, create the Docker containers, and at the end we can browse our application to see whether it is running or not. So in order to do that, let's go and run directly this script here. Okay, so in order to do that, we can just use this script. Okay, and the name is run. Okay, run store services .sh. Okay, okay, uh, yeah, this is should be okay. So let's see, if you run, you have to use because the current directory you can use like this, and the file name you can space like this. Then it will start building everything. Okay, so you can see we don't have anything here. Okay, later we can see everything, it will be get created. It will create 3 Docker images and 4 and it will create 4 containers. Okay, then we'll see how we can run our applications by using the, we can browse our application using the local host and the 8080 port, because if you see, we have mentioned in our storefront container, right, it is exposed using 8080 port. Okay, now if we go to the UI here, and if you see, now you can see here, it is um, 3 images got created. Okay, and containers, still no containers available, not started yet. It will take a couple of times here. Okay, so while it creating these containers, let's go and discuss about the other things, what we are going to complete here. Okay, so once this is done, we can access our applications using this. Okay, we can browse it, or we can call the application simply using the call command. Okay, that I'll show once it completes. And at the end, we can also uh, clean up it by, in order to delete or remove these containers, first we have to stop it. Okay, stop the container using container id, then we can remove it. And in order to delete it, the images, we can use docker on the docker remove rmi, that means remove images with image id. So we cannot directly remove of okay, so we can only delete the docker images if it is not used by any container. So first we need to stop the container, then we have to remove the container, then we can remove the docker images. Let's see whether yeah, if you see here, it is already in the docker images and containers are got created. Just now I have done this, run this docker images command, and I can see these are the images are available. If we go to the UI also, you can see these are the 4 docker, these are the docker images and containers. If we see, these are the containers. Now it's running. Okay, in order to browse this, if you go to the browser and try to use localhost 8080, okay, you can see this is the application running. Similarly, if you want to call it, right, you can use the call command, call localhost colon 8080. Okay, you can see it shows contours of pet store. And this, if we can see in our source, and if you go to the storefront application, and here the index html, it shows this value contours of pet store. Okay, so this, it displays here. So that means our applications is running, and this is running with using 4 different microservices. And how we have done this, this is basically we have done by containerizing or dockerizing the application with 4 microservices. We have created we have created three Docker images and used one external rabbit message queue microservice image, and we have created the constant containers and running that in the Docker desktop. So here it is basically, the containers are running in the Docker desktop environment. Okay, now if you see here, given it is, I think, Docker volume. Okay, here it also created Docker volume. If you can see here, okay, I think this one now. Here for that is for the rabbit message queue. Okay, okay. Now let's. So this is what we have done. But we created the Docker images and the Docker volumes. Sorry, Docker around the Docker containers using the Docker CLI command. Okay, we have run this bash command. This is nothing. The Docker. It uses the Docker commands only. Now there is another way we can do it by using Docker Compose. So what is the disadvantage is here? Um, Here the thing is, in order to, for example, we created this. So if we want to remove these images or remove these containers individually, we have to run these commands, Docker CLI commands. Okay, we cannot as the whole application as as a whole, we cannot start it or we cannot delete it. Okay, also the other thing is, for example, for dependency, right? We cannot check the status. Okay, and we cannot wait if any microservice waits for any other microservice to start. So those kind of things we cannot include in this case, right? So in order to manage that, we have another tool called Docker Compose. So let's go and discuss what is this Docker Compose here. So Docker Compose, it is a tool that can manage multi-container Docker applications. Okay, so we can use a single uh, configuration file, and there we have to mention what are the different components or the microservices that we are going to build and we are going to run. Okay, so instead of starting each container manually with Docker run, right, what we did just right, uh, we can write a configuration file. So that will help declaring all the services, networks, volumes in one file and bring them off with single command. So let's go to that Docker Compose and we'll discuss what is that. Okay, so if you come here, under this we have a Docker Compose YAML file, and if you see here we have defined, okay, we have the services. Under this we have defined these services here: rabbit message queue, order service, product service, and storefront service, and a network. Okay, so these are the components you can see under the service we defined here, rabbit message queue. So if you go to rabbit message queue, we have mentioned what is the image it's going to use, the name of the container, restart policy, what environment is going to use, what ports it is going to use, and health check. This is additional thing we can do that we cannot do in by using the Docker run command. So this is one advantage of using the Docker Compose. So we can check the health of the um, any of the service. Okay, so if you see rabbit message queue use another service. Okay, uh, uh, so it used the health check here, and the volume to include the plugins. It uses this external file to read what are the different plugins are defined there, and also it uses this network, and this network is got created using this. Okay, network. This will create a driver type is bridge, and it will create a network with name of backend service, and it is referring, and the rabbit message queue is referring this here. Okay, similarly for order service, these are the command we have to mention the image here. Okay, first it will, in this case it will build the, here if you see we have directly mentioned the image, but here we have mentioned the build. So it will first build the image, then it will use that order service, you can see. Okay, whatever it created, it will use that as a image, and the same thing like if we have the container name, restart, ports, health check, okay, environment variables and networks. And one more thing you can see, depends on. So this is another advantage. So if any image or the service depends on other service, that we can mention in our Docker Compose. So here the other service depends upon the rabbit message queue. Okay, so condition is service healthy. That service should be healthy. Okay, if rabbit message queue is available. Okay, next, similarly product service, it is building here, then creating the container, and these are the different parameters what we have mentioned here. And similarly for storefront, and this is the port what we have exposed to access it. Okay, yeah, it's everything is self-explanatory here. We can go through it and just try to understand it. Okay, and before to that we can remove this. So through command line we can remove this. We can use these commands here, uh, what I have mentioned, right? You can use this to remove the images. Okay, or you can use docker rm. Before to that you have to stop, then you have to use rm with the id, container id. Okay, how we can get that? We can get from here. Okay, mm, here we can type docker ps, sorry, Docker ps. So you can see the running containers. It will show the running containers. These are the 4 containers is running, and this is the container id. So while deleting it, then you can use this. Suppose you want to delete one of these, then what we have to do first is we have to docker stop it first. Docker stop docker ps. Okay, so how to do that is, yeah, so what you have to do, just docker stop, and it means suppose you want to remove this. Okay, the storefront, then you have to mention storefront container, you have to remove, right? Then you have to first stop it, then you have to remove it. So in order to remove it, you have to use rm. Okay, you can remove this. And if you want to remove the docker image, then what you have to do, you have to get the id of the images. Okay, so the storefront image id is this. Okay, and in order to remove this, we can use docker rmi, I for image, and you have to mention this id. Okay, so you can see here on the storefront got deleted. If you see and come to the ui also, you can see that same thing, docker images. You cannot see here the front door, so it got deleted. So now let me delete everything here. So in order to do that, let me select all, uh, quickly to delete. We can delete from here as well. So I'll delete all these containers from the desktop, on Docker desktop. Okay, and image, let me select all and delete everything. Now what we'll do, we'll again run using Docker Compose. Okay, so in order to do that, what we can do, we can so we have cleaned up this. Okay, what we have run using the Docker CLI command. Now we'll use Docker Compose to run our application. Okay, so in order to do that, what we have to do is we have to use the Docker Compose op command. Okay, Docker compose of command here. So let's start. So what it will do here is, again it will it will build the Docker images. Okay, then it will create the containers like how we did in our script as well. Okay, but in script, right, we don't have like a dependency, or we cannot check the health check. Okay, so those things we cannot do. So in Docker Compose we can include all these things. Okay, dependency as well as health check, and those things we can do. And the most important thing is that we can do docker up, docker compose up, and docker compose down. So docker compose down means it will again delete everything, clean up everything. Okay, so that is the advantage. That means as a whole it will run all this, build all the docker images, create all the docker containers, and run. Okay, and if we use docker compose down, it will remove everything. Okay, not one by one like what we did using uh, docker CLI command. Okay, so it will take a couple of minutes to do these things, but it is more faster than the previous. Yes. So let's go to the desktop here again. Here you can see, and here images are created. We can see Docker images are created and containers. You can see the containers are starting. These are the containers now active now. Okay, but these two containers still to become active. Okay, you can see it started 27 second, 20, 30 seconds, something. Okay, it's not started. These are not started. Okay, now you can see it is started everything. I think yeah, it is going to be end. So if you see here, it is completed, everything is running. Now it shows like view in Docker desktop. If you want to see, just type v. You can see it is, you can see everything is here. Okay, everything is running. Now if you want to view config, right, configuration, if you want to see what configuration we have used, then you can type o. This is the configuration, this is the file we have used, right, Docker compose file, configuration file we have used to build and run this application or the containers. Okay, and double, if w, if you want, you can watch. If you want to watch what is happening, right, you can do that. Okay, so these are the commands. Yeah, so everything is running now. If you want to, whether our application is running or not, that if you want to see, then again what we have to do, you can browse it again. Still is running, right, just let me refresh. So refresh, that means it is running. Okay, and also you can run, you go to another here, and if you call it, right, localhost, localhost, you can see this is a change. Okay, right, so now let do a change here. Again what we want to do is, let in our application, we'll do some changes in the front end application. Let modify this index.html. So what I to do is, so I have just added welcome. Okay, let me save it. So what we can do, again with these changes, let me uh, delete everything again. Let me select this, delete. Then I'll delete the images. Okay, so now what I have to do again, I'll run this Docker compose. We can stop it. Either what you can do is, if you want to stop that, you can write Docker compose down, but we have already deleted those things, so it will not do anything. Okay, now what we can do is, again let to do Docker compose up. It will take a couple of time, couple of minutes to finish it. So what we basically learn here is, uh, learn how to Dockerize the microservices using Dockerfile, and how to create the Docker images, and using the Docker images how to create the containers. And we run these microservices two ways. One is using the Docker CLI command, that we can do directly running from the command line, or by running the script. So the bash script what I just mentioned here, we can run it, and it can, everything will be run uh, together. I mean, it will build and create this uh, Docker containers. Otherwise, we can also do it using Docker Compose. We also explained like what is the advantage of using Docker Compose. So the main advantage what we'll get is, we can use the health check, and also we can include the dependency in our Docker Compose file. Okay, so in this Docker Compose file, you can mention, if you want to directly refer any image, directly you can refer the image, or if you want to build, you can build it and use it to create the container. Okay, Yeah, so this is for this session, but in the next session we'll discuss how we can run these microservices using any orchestrator tool. So what is orchestrator tool? Where our Docker images will run as container, and that orchestrator tool mainly create that containers and it will manage those. Okay, so there are various tools are available, like you can use locally if you want to test it. You can use Minikube or Kind or any service provider tools like Azure Kubernetes or EKS from the uh, Amazon uh, services. Okay, AWS, I mean. Okay, or Google Cloud. So there are different tools are available. So in the next lab, we'll try to learn how we can run this using these orchestrator tools. But what is Docker here? Basically, it is a containerization tool. Okay, or we can say it will just containerize, or it will mainly create the images. Okay, and locally we can test our application by running using Docker CLI commands or the Docker Compose. But if you want to run it externally in any orchestrator tool, then we can use the Minikube, Kind, or any cloud provider orchestrator tool like Azure Container Kubernetes. Okay, yeah. So so next class, in the next lab, if you see, we can learn all these topics here. What I mentioned, like using Minikube, or how we can do it using Kind or AKS. Okay, that we're going to discuss. I'm just waiting for this. I think it will take few minutes to build that. Let's see how it is. How many images are created. So the images are got created out of containers. Nothing is started yet. Okay, so hopefully it will create with the same thing with the new changes. So I'm just not waiting for that. So so you just follow this. I have mentioned all the instructions, how to create the Docker images, how to create the container instances using either of these Docker CLI commands or Docker Compose. You can follow that. If any doubts, just give the feedback, provide your comments, and subscribe my channel and share it to your friends and colleagues.